Hey everybody. I'll try to get in more of a like Mickey Mouse happy mood. Ho. I know I don't know, I guess it's just the quarantine getting to me. Ugh. Anyway, so here's the do it yourself part. The first one says find the exact value of sine of 165 degrees. And so since this is the over 2 section, the a over 2, instead I'm going to look at this as sine of, and double 165 is 330. 330 over 2. So that means that in my formula, well, first, sine of 165 degrees is quadrant 2. And in quadrant 2, sine is positive. Okay, so I know that this is positive, but then from then on, I just kind of plug and chug. So I have 1 minus cosine of 330 over 2. And now we just got to solve it. So 330 is this degree all the way over here, which leaves just a gap of 30 degrees before you complete a full circle. So my reference angle is 30 degrees. And in that quadrant, cosine is positive. So here I have square root of 1 minus, and then cosine of 30 is square root of 3 over 2 over 2. And just like we did last time. So that 1, I changed the 1 into a 2 over 2. Over 2. So that becomes 2 minus square root of 3 over 2. Now, dividing by 2 is the same as multiplying by 1/2, so you can look at it like that. There's a lot of ways to deal with division. It depends on how you look at it. So what I did was I said, oh, dividing by 2 is the same thing as multiplying by 1/2. They're identical. So we get 2 minus square root of 3 over 4, but then the square root of 4 is 2, so 2 minus square root of 3 over 2. Right, let me shrink everything. But that ends up being your final answer. So it's very similar to the one we did before. Okay, the next one, find the exact value of tangent of 15. Now this is one where this is the same thing as tangent of 30 over 2. Now everything's in quadrant 1 for this problem, so everything's going to be positive. So, I keep on doing that. For tangent, it doesn't matter. It'll work itself out. You can see how it gets with this section. It's just blah. So I'm going to use this formula. And so we're in quadrant 1. Sine of 30 is 1/2. 1 plus cosine of 30 is square root of 3 over 2. And all I got to do is work it out. So I have 2 over 2 plus square root of 3 over 2. Okay, which ends up being 1/2. 2 plus square root of 3 over 2. And for the same reason as before, this is where the halves cancel. Let me try to give myself more room. You know what? We can instead think of it as just multiply everything by 2. Why not? And so notice the 2's cancel. And you're left with 1 over 2 plus square root of 3. Now again, there's a square root in the denominator, so if you wanted to rationalize it, you would do 2 minus square root of 3, the conjugate, to the top and bottom. And it actually works out rather nice. Top times top is 2 minus square root of 3. Bottom times bottom ends up being 4 minus 3. So my answer ends up just being 2 minus square root of 3. If you had used the other formula for tangent, you would have gotten that answer right away. So it's one of those where it's kind of, you learn after the fact, oh, I could have done that a quicker way. But it just kind of bites you in the butt. All right, next question. Find sine b of negative 1/3 with b in quadrant 3, and find all 6 trig functions. So we did this before. If b is in quadrant 3, that means that b over 2 is in quadrant 2. So, working this out, there's quadrant 3. Here's my generic triangle. Here's b. So opposite, hypotenuse. And this one has a rather weird other value that we haven't seen too much. So a squared plus negative 1 squared equals 3 squared. So a squared plus 1 equals 9. A squared equals 8. And so when you take the square root, you get a is equal to the square root of 8, which is just 2 square root of 2. So that's what this is. Oh, negative, because it's in quadrant 3. All right, so now let's go ahead and find all our trig functions. So I know that sine of b was given to me, but the main one I'm going to use is cosine of b. Cosine of b is negative 2 square root of 2 over 3. All right. So the first one I'm going to find is sine of b over 2. But this angle is in quadrant 2. And in quadrant 2, sine is positive. And so we end up with so b over 2, so we end up with so sine, since it's not cosine, it's going to be a minus, so this is 1 minus cosine of b over 2, and we just crank it out. So square root of 1 minus negative 2 square root of 2 over 3, got a double negative going on there. And so here we have 2 over 2, or 3 over 3, because that's the denominator, plus 2 square root of 2 over 3, all divided by 2. But like I said, dividing by 2 is the same as multiplying by 1/2. So this is just 3 plus 2 square root of 2 over 3, that's the numerator, times 1/2. And so we end up with 3 plus 2 square root of 2 over 6. Now this one I'm just going to leave as is, because this is nasty. That is no fun. So I'm just going to leave that alone, and that is my answer for sine. You can try to rationalize it if you want. Actually, if you do rationalize it, you end up with but I would never make you do that. So I'm happy with this this one right here. So that's sine, and again, you flip it to get the cosecant. So I'll shimmy it over here. Cosecant of b over 2. Oh my god, what's doing that? Is the flip version. And I'm perfectly okay with with this 2 square root of 2. You just flip it. So there's cosecant, there's sine, and now let's work on cosine. Let me make this small. I just picked this problem from the book, so not a fun problem. So cosine of b over 2. Very similar process. Cosine in quadrant 2, cosine is negative. And so I have 1 plus cosine of b over 2. So a lot of the same math involved. We get negative big square root 1 minus 2 square root of 3 over 3. Yeah, over 2. Skipping a couple steps because we did something just like it above. We end up with 3 minus 2 square root of 2 over 3 times a half. And so you end up with negative big square root 3 minus 2 square root of 2 over 6. Right, and there's cosine. Very nasty looking. We flip it and we get secant. And then for tangent, I'm just going to use the formula because I don't want to have to deal with sine over cosine because it's over, and that's not fun. So this is secant of b over 2, and we just flip it. So negative 6 over 3 minus 2 square root of 2. So now the last one is tangent. And so for tangent, I'm just going to use the formula. Okay, so I'm going to use the formula with just one thing in the denominator because having to fix the denominator to make it one thing is kind of annoying. So I'm going to use this formula, 1 minus cosine A over sine A. Oop, too much. There we go. So for tangent, again, it doesn't matter because it's going to fix itself. The answer is going to be negative. So anyway, tangent of b over 2 is, as Gilbert totally forgot. See, these formulas are hard for me to memorize too. 1 minus cosine A over sine A. So this is b as our variable. Right. So this is 1 minus negative 2 square root of 2 over 3 over sine b, negative 1/3, and we just chug it out. So 1 plus 2 square root of 2 over 3, and again dividing by something, dividing by 1/3 is the same. I don't want to be. I'll hold off on that. So I've done these a lot, so my brain kind of knows where to go, but I don't want to make y'all sad. Okay, So we have this over negative 1/3. Right? So that 1 is 3 over 3. So this is 3 plus 2 square root of 2 over 3. And then this is divided by negative 3, or negative 1/3. And so I can just multiply everything by 3. So the 3's cancel. And you end up with 3 plus 2 square root of 2 over negative 1, which just makes everything negative. Now you flip it, and cotangent of b over 2 is just the flip version of that. So negative 1 over, I'll just write it like this, 1 over negative 3 minus 2 square root of 2. You know what? That's so nasty, I'm just going to say, okay, we're fine with that. Okay, so there we go. We have, this was by far the hardest one. I would never do that to you on a test or anything, but you might see one of these on the homework, because remember, the numbers are randomly generated. So you may be lucky and you may get one of the 3, 4, 5 triangles, or you may be unlucky and you might get this one, which requires a lot more dedication to solving it. Anyway, let's do these last 3 proofs and we're done. So this next one is secant squared of a over 2 is 2 secant a over secant a plus 1, and they want us to prove it. So we're going to do something very similar to what we've done in the past. All right. So I have 2 secant of a over secant of a plus 1. Now secant is just 1 over cosine. Okay. I don't like the fact that there's the cosine in the denominator, so I'm just going to multiply. This is another way to do it. In the past, I've said cosine a over cosine a, and I've manually distributed to everything. But if you don't like that, just be sure to give everything the cosine and you should be fine. So if you want to, you can just say, oh, let me just give everything cosine. Okay, so that means these cosine a's cancel, these cosine a's cancel. And so we end up with 2 over 1 plus cosine a. And notice that this is the formula but flipped. So the formula for cosine squared of b over 2 is, a over 2, is 1 plus cosine of a over 2. So you square both sides so the square root's gone from the formula. So notice that this is very similar to this. It's just it's flipped. So that means this is going to be 1 over cosine squared a over 2 because it's the flipped version of it. And then 1 over cosine is, again, secant squared. And you get your answer. So that's the proof for that. All right, number 10. Tangent plus cotangent equals 2 cosecant. So I'm going to work with the more complicated side. And I have tangent of x over 2 plus cotangent of x over 2. Now, as far as my answer goes, I know that this is 2. Oh my God, why? 2 over sine of x. Okay, which means that sine is in the denominator. So when I'm doing my proof, I want sine to be in the denominator because my answer has sine in the denominator. So I want to see a sine in the denominator. So when I look at my formulas for tangent, again, the formula is at the very top. I want to pick the formula that has sine in the denominator. And it says Gilbert as he immediately forgets it after looking at it. 1 minus cosine over sine. So this tangent I can write as 1 minus cosine of x over sine x. Because it has my sine in the denominator. Plus, now this cotangent, I could flip it because that's really all it is. But notice that when I do that, I don't have sine in the denominator. I got nasty stuff. So instead what I'm going to do is I'm going to look at the other form for tangent. And the other form for tangent, remember tangent of x over 2, I'll write this to this side. So it can be two things. It can either be 1 minus cosine x over sine x, or it can be sine x over 1 plus cosine x. It doesn't matter. So this one, I chose this one because it has sine on the bottom. Now this one has sine on the top, but when I do cotangent, it flips it, which will make it have sine on the bottom. So this is 1 plus cosine x over sine x. So for the first tangent, I used this formula. For the cotangent, I went ahead and I used the other formula. Because by flipping it, it puts the sine in the bottom. Now they both have sine in the denominator, so it's 1 minus cosine x plus 1 plus cosine x over sine x. Negative cosine plus cosine cancels. 1 plus 1 is 2, which is 2 cosecant x. There you go. So that one, if you approached it from the wrong angle, you would have to have done a lot more algebra to get it to work out. Anyway, on to the last one. So for this last one, right off the bat, I'm going to say let u equal cosine of 2 theta. I do my variable substitution. So that means that 1 minus 2 cosine of 2 theta plus cosine squared of 2 theta becomes 1 minus 2u plus u squared, which is u squared minus 2u plus 1, which is u minus 1 squared. Okay? So, what that means is all of this is just cosine of 2u minus 1 squared. Okay? Now, if you recognize that it's a perfect square, you can technically go straight from here to here. It's fine. I won't get mad at you. But if you need to do the variable replacement to see that this is something that can be factored, go for it. Okay? So now this is almost the formula. What I want is I want to change this up a bit. Remember, my formula has a 2 on the bottom. Okay, so what I'm going to do is I'm actually going to multiply by 4 over 4. And the reason is What am I picking? 4 cosine of 2 theta minus 1. Parenthesis nightmare. You know what? I'm just going to put 2 theta. Okay, over. The reason is I want to turn this 4 into 2 squared. Because that's what it is. Now I have a square over square, so I can combine the squares. Make sure I did it right. Yeah. Okay. So all that's left is, notice that this is the formula. Now, I want to show you why this isn't exactly what we want. We want 1 minus cosine of 2 theta for us to use the formula. So what I can do, and I'm kind of doing this work on the side, it's really my fault. I should have taken a different step in the beginning, but I don't want to start from scratch. It's a trivial step, but notice that I can rewrite it. I can take a negative out. So this ends up being 1 minus cosine 2 theta, what we want. Now the reason that it doesn't matter is when you're squaring everything, what happens to that negative 1? Well, that negative 1's pointless because you're squaring it. So that's why in this next step, I'm just going to switch the order, and it's legal because we're squaring it. Okay? If I had rewrote this as 1 minus u squared and then did my substitution, it would have avoided that whole thing. So I apologize about that. But anyway, so now I have that, and that 4 times 1 minus cosine of 2 theta is sine squared. So I have 4 sine squared squared, which is 4 sine to the 4. I just feel like I'm not on my A game this week. All right, anyway, let me know if you have any questions. This is the toughest of the proof questions so far. But please let me know. So far, not many people have come to office hours. Make me kind of sad. But please remember, my office hours are from 10 to noon and from 1 to 2 every day. So please stop by and we can Zoom chat and we can work out problems together. Anyway, have a good day.